This is the Math Map Book Club, where ordinary parents encourage one another to develop an extraordinary appreciation of math. We love what we know and struggle over the unfamiliar. Through weekly conversation and exploration among friends, we can begin to enjoy ideas that seem difficult. Join our book club as we discover how math helps us to know God and to make Him known.
Hi, I'm Lee Bordens, and it's Wednesday, November 13th, 2024. Welcome to the Math Map Book Club, where Kirsty Gilpin and I discuss lessons each week from our math curriculum for families with students enrolled in classical conversations communities. The academic semester is nearing an end as we approach the holidays. So, Kirsty, I think we're in the end stretch here. What's for today? You're muted, Kirsty.
Sorry about that. So we're actually going to preview next semester. We're going to look at lesson 16, which is triangles and circles, which is actually trigonometry. And so this is a place where Lee is really trying to use descriptive titles that maybe aren't going to trigger, right, to use that word, any feelings of anxiety that are hangovers from our own imperfect educations. And I use this lesson as a great example of where conventional math curriculum and teaching really let students down, because if you remember back to your own education, chances are you may have been in a geometry or an algebra 2 class, and on Monday your teacher said, we're going to learn about trig today. This is what sine, cosine, and tangent are. Now go home and do these problems. And by the end of the week, you probably were expected to take a test and remember this. And what most people remember is SOHCAHTOA, which is just a mnemonic device that doesn't really mean anything if you don't understand. And so I think this really, to me, is a great place to demonstrate the power of classical learning, because we can introduce our children to the grammar of trigonometry and they can memorize what sine, cosine, tangent are, even what a secant, cosecant, and cotangent are, and they don't have to use it. They don't have to understand it, but they can be memorizing for years so that by the time they get to the challenge years, they're ready to actually put that knowledge into practice. So it's just my favorite example of really where the classical model of learning and is really going to make this huge difference in math. So all of that to say, I am excited today to reintroduce Babs to you all. You're all familiar with Babs as one of our curriculum assistants, but she's also been a pilot tutor for many years now. So she has seen the good, the bad, and the ugly as we have developed these lessons that you're now all using. And she and Jill especially can probably tell you that what you're seeing is so much better than where they started. But Babs is going to lead us today, and I'm really excited because I know that she's got some great wisdom. And I know that sometimes when I'm leading, it may not always feel exactly what it looks like, right? Like what you might do as a tutor or a parent in your home, because I just have a different insight into the curriculum. And so I think when we're able to have Babs and Jill come on, they can give you a picture of maybe how that that outline that Lee has given us, that best practice that Lee has given us, how that can be tailored to meet the needs of your class. And they just bring in a different flavor and a different idea. So I know that you're all going to be encouraged. So with that said, I'm going to mute myself and turn it over to Babs.
Okay. So just so you know, like Zoom and PowerPoint are not my favorite people. And so I've been practicing this morning how to present so that you get to see all the beautiful slides. So hopefully I will do this correctly. So I guess I need to make sure that I have the ability to share. Let's see, share. Let's see. Ask permission from Emma if I can share. I want you to see my pretty slides. it says I can't. So let's see.
All right, so if Emma doesn't hear that request, and then you can always send them to me, Babs, and I can be your share,
I
your
just
slide person.
accept,
Oh,
oh, sorry. I just accepted the request. It seems like there's multiple presenters right now. Just kidding. Looks like you got it, Babs.
Yay. Okay, good. All right. So I'm a little different than Kirsty, obviously. And so mine will be a little different, but hopefully you'll be able to kind of follow along. And this is what I would do in my class. And I did have some guinea pigs last Friday to help me, make sure everything that I'm going to share with my students would be beneficial. So the first thing we like to do is look at our scope and sequence page. We call it the math map, and find our spot. What I really love about this week is that it's week 16, which is where we've come back from break, right? And so hopefully we're refreshed as directors. Hopefully our students are refreshed. They've had a break. And so it's nice to kind of come back to this page to see, look, we're already halfway there. And so they can kind of see where they are. So we'll do that first in our communities. And I do like to kind of show them, or just kind of remind them, there's still 30 booklet titles. We didn't add any over break, right? And so it makes you feel better knowing that once CC's done, we only have 30 booklets. And so we'll be done when CC's done. Okay. So our integer of the week, we're going to do the number 30. So I'm going to ask you guys, what are some ways that you would represent the number 30?
XXX.
Okay.
3 and a 0.
Mm-hmm.
The words 30.
Yes.
2 times
think of-
3, 3 times 10.
Right.
And I think about it as a half an hour.
Ooh, good.
I think about it as 30 days has September, April, June, and November. So
Yes. I'm glad you said that. I love that. But I memorized that when my kids were little. Loved it. Can you think of anything, do you know any interesting facts about the number 30?
Well, we can, thinking of them in relationship to 30, 60, 90 triangle.
Ooh, good.
I'm thinking about some months are 30 days.
Mm-hmm.
An even number. Did we say that?
That's right. It's an even number. Mm-hmm.
And a composite number.
Ooh, good.
Is
So
that
I
the
did look
age?
this up. Oh, go ahead.
Is that the age Jesus was when he began his public ministry?
Yes, I'm glad you said that. So one thing I found was it said in the book of Numbers, priests were only allowed to begin their service in the temple at age 30. And then also Jesus's ministry, he started when he was at the age of 30. So good. So you kind of bled right into where does this number appear in the Bible, right? So what are some other times that you remember the number 30 in the Bible?
Is that one of when Jesus says some will have 30-fold and others 60-fold and others 100-fold? Am I remembering that right? Is that one of those numbers?
I think so. Yeah. So I had to look it up. I did see King David reigned over Israel for 30 years, and that meant it was a time of stability and prosperity for the nation. Joseph was 30 years old when he began serving as Pharaoh's second in command. And do you remember how many pieces of silver Judas?
Yeah, 30.
30.
Yeah. Yeah. And then some other ones that I looked up because I was like, wow, the number 30. Look, I really didn't realize how much the number 30 had been used. There are 30 teams in the NBA. My boys in my class like that. I have all boys. There are 30 minutes is the recommended amount of daily physical activity for adults. and and the earth takes approximately 30 seconds to rotate about its axis. So I thought that was pretty cool. In my class, this past week, we actually used the number 30, and they spent a lot of time on the calculation part. They wanted to see how many equations, and you guys gave us a couple of them. Can you think of any other equations? I know somebody said, I think somebody said like 2 times 15. But can you think of some other equations where the sum or the product is 30?
6 times 5.
90 divided by 3.
Or 360 divided by 12.
Ooh.
I was thinking the prime factorization is 2 times 3 times 5.
6 squared minus 6.
So what I like about using the integers for this exercise is that your numbers can be big or small, or you can have, in number knockout, we could only have 3, right? And so now we could have more than 3, or we can have bigger numbers than we might not be able to roll, on one of the dice. And so, all right, anything else you can think of that reminds you of the number 30? Oh, does this number appear in other books? I thought that was a hard one.
I don't know about books, but I tell my kids we're not a real adult until we're around 30.
That's probably true. That 30 is probably a good number. Yeah, very good number. So somebody had suggested that there could, and I don't know, but that there are probably a lot of books like saying 30 days, like 30 days of no sugar or 30 days of
Whole 30. Yeah.
Yeah, Whole 30. There
Yeah.
you go. There's probably those kind of books out there. And then somebody was like, well, the 180 days, the book because 180 is divisible by 30. Maybe you could stretch it, to that. All right. So anything else you want to share about the number 30? Because we could steal some time and when we talk about our
I quick Googled it because I remembered when Kirsty was doing like the happy numbers and things like that. And so I didn't find the happy part, but it did say that 30 is a cannonball number because 30 cannonballs can be used to build a square pyramid, and that in Western tonal music, 30 is the number of major and minor keys, including enharmonic equivalents for those who have Challenge 3 students.
Wow. Very cool. All right. I'm going to go to the next. I'm going to stop this and go to the next slide. So this is an interesting one. And this is funny because when I was preparing, I forgot that my kid is number 30 on the basketball team. And he was like, the greatest basketball player ever, his number is 30. And I was like, oh, yeah, exactly. Right. I knew that. So I was like, well, I'm just going to give him a shout out, give him his own slide. And so I can give him a shout out. So this is my son. He is a junior this year and he is number 30. So, all right. So now let's look at our exordium. Let's look at our art for the week and start the timer here. So we're going to go really simplistically. Okay. Because I want to kind of bring it down to what our kids might say. So what do you see in this art? We're trying to use our common topics. What do you see?
Repetition of shapes.
Ooh, good.
There are 30 pairs of these, I don't know if you would call them like a needle almost. But you have blue, green, like as you go around the circle. And I just counted real quick, and there are 30 pairs, so that was fun.
Wow, that was 30.
Wow.
Hey, hot dog.
I see symmetry, radial
Ooh.
symmetry specifically.
Mm.
And maybe almost kind of concentric circles.
Ooh.
If I'm going to answer like a 12-year-old, I'm going to say, I see a circle.
Right.
That's a good point. Thinking like the kids in my Challenge A class. I see blue and I see black and I see things. It looks broken almost with all the different segments divided up.
Mm-hmm.
And the girls would probably say, I see flowers.
Yeah.
It looks like how you cut a pie or a cake at a very large birthday party with only one cake. So many pieces.
That is so good. Yes. Maybe you didn't realize that many people were going to come, and now you're like, okay, I have to cut really tiny slices of cake. That's good.
I think it looks like a kaleidoscope.
Oh, yes. Yes, kaleidoscope. So what can we learn about math by looking at this piece of art?
Well, there is a way to fit triangles into a circle.
Ooh, good. Trying to bring in that title. Mm-hmm.
There's all kinds of patterns in math.
Exactly. Yep.
They had to do a lot of math to come up with how many of the white pieces of glass and how many of the yellow pieces of glass that they needed for this whole thing.
Wow, that's a good point, because I was telling somebody the other day, I read a book and I don't know the name of it, but it was talking about how back then when they actually spent a lot of time creating these types of windows, just in general, that time period where they were building the art, they were much more intricate. Like they paid more attention to the detail of those buildings. And so, yeah, I mean, even math could have been used to create just this art that they used in this window.
I think also by now my class would be familiar with the idea of taking something apart and looking at what makes it up. And so it relates to math that you can look at one small piece to understand other pieces.
Mm-hmm. That's good. Well, what can I learn about God by just looking at this piece of art?
So when I look at this art, the first thing that came to my mind is the rotunda of the state courthouse. If you go to the state courthouse tour and if you look up, that's usually the mosaic window that you see, the stained glass. So it kind of reminds me of God's justice.
Similarly, I was thinking the same thing. It makes me think of looking up in the scripture. I look to the hills from whence cometh my help, looking up and remembering to think of God in the midst of whatever it is that you're doing.
Mm-hmm.
So my daughter's looking at this, but doesn't want to come on camera. But she said when she looked at it, she sees the dark in the center and remembers how in the beginning, everything was dark, but there was God. And as he created more and more, we got land and flowers and trees and more colors and more variety as it spread out from that center at the beginning when there was darkness.
That's great.
I also have to think that God gave this creative ability to design and construct this to a person or several people. And it's because of their abilities that are God-given that we can enjoy the beauty that we see in this, which I assume is stained glass. Mm-hmm. And, because he's the creator of everything and he's the one that gives us our creativity. This is just one more way that someone or some people have given glory back to God.
Yes. And it really talks about him being our creator, right? What you just said, and how creative he was. We've been studying about in challenge A during the research strand, all the different animals and that kind of thing. And we've already learned about how creative he was there. And this is just another reminder about how creative God can be, right?
I think the circle shape makes me just think of the unity, like God's he's just encompassed. But like then there's these three layers. Like I don't know, the kaleidoscope thing, we're just not going to come to the end of the possibilities and of knowing who God is.
Oh, that's so true.
I look at the order too and the pattern. It's not like a bunch of stuff just dropped into the middle. It's very intricate and very orderly in the way it's laid out.
Yeah.
Well, and to that point, as I was, I guess, contemplating this more, the very outer, like it looks like there's things that are circles, like little flowers that have 5 parts, and then there's they make triangles, and the very like the last pieces that kind of go out. I was just kind of looking at those, and there's actually 32 spokes, and then 16 of the roses, and then 16 of the triangles. So it's very, very, like you said, orderly and mathematical.
Mm. I like how there's light in the center of this piece. And I don't know if it's because the background is black, but I feel like this piece just stands out because it has that black in the background. So could that be an indication of when we are the light, right, in the darkness, that we're shining the light for Jesus? So I wanted to be really simplistic today because I just want to encourage you that we don't have to have this giant theological discussion with our students. Now, sometimes it gets to that point, and I'll just tell you that every year that I've been going through the math map, my conversations are different with every class. We don't have the same conversations. They're different students. They have different backgrounds, right? Because we're going to see this art every year. And so just so you know, the conversations aren't going to be the same, right? Your students are going to be growing and maturing. They're going to have different experiences. And so those conversations are going to be different. And eventually, I do think the older they get, the more profound they are. But they don't have to be this big, giant discussion that we normally can have, right? Because we're adults and we've had more experience and we can see more. But that doesn't necessarily mean that it's not a meaningful conversation. So I just wanted to kind of just remind you that just these 3 questions. What do you see in the art? What can we learn about math by looking at this piece of art? And what can I learn about God? Those could be the only questions I ask this week, and I'll still have plenty of conversation material. And I didn't really have to add anything, right? So it's not like I have to prepare so many things to talk about. I'm letting my kids share from their experiences. And just sitting back and listening. This week, I fell into my house. And so I spent a lot of time yesterday sitting more than standing. And I was kind of more restful, kind of letting the kids talk more than normal. And I was just sitting there thinking, you should do this more often. You should let your students share more because they have a lot to say, and what they say is very important. And so I think sometimes we might maybe we talk too much, or maybe we're asking too many questions. We don't have to have a planned out devotion, right, to actually give the students. We can just talk, through just those 3 questions. Okay, so I'm gonna do something a little bit different. I felt like this week was a lot. Kirsty was saying it's a lot of trigonometry in this 1 week. So I decided to go back through just for my own personal help and look for where I've already seen some of these things that are in this booklet 16. So in week 9, we introduced our students to quadrants. And one thing I did in my class is I asked my kids to try to memorize as much as they could about the 4 quadrants. And then when they came into class, I would let them come to the board and they drew the coordinate plane, and then they labeled the quadrants in the right order. And if they could remember, they would put, what was positive or what was negative. And so I was glad I did that, because this week we're going to see these same quadrants again. And so even if they didn't memorize it, a couple of weeks ago, they've seen it. So that's one thing that's going to be familiar to them. In week 10, we introduced them to angle measures. And so, I asked my kids, hey, if you want to pick something to memorize this week, I would pick out maybe a set of like degrees and radians and see if I could memorize, maybe 2 or 3 things. So like maybe 90 degrees would be pi over 2, right? Or 60 degrees would be pi over 3. And so we're going to see these same things again this week. And so this is another thing that's going to be familiar to our kids that they've at least seen before. And then in week 13, we introduced the unit circle. And so, when you look at the unit circle, it's part of our charts, it's part of some of our pages. Just in case you haven't got to that point yet, maybe you haven't got to week 13 yet, they have seen this before. And so really my point in doing this is really, I did it for myself as I was preparing to lead, but also to help us realize that maybe some of these things are slowly becoming familiar to us. The more we work through these booklets, the more things are going to be, more familiar to us. And so I kind of wanted to just put this on the screen for just a minute to let you look and see. There are at least three things that I found that we've already at least looked at or covered in previous weeks before we jump in to week 16. So now here we have the invention page for week 16. And so at first glance, we might go, wow, that is a lot of stuff on this page. But now that I've just shown you, okay, we have seen some of this before. Do you see anything on this page that talks about quadrants?
Right at the top, first quadrant coordinates.
Yes. So that should be a little familiar. We're in quadrant 1. We've taken quadrant 1 and kind of blown it up a little bit. Do you see angle measures here?
Yes.
Yeah. Now I don't know how big your screen is. I actually blew up mine because I needed to be able to see it better. But could you find what radian is associated with, let's say, the 30-degree angle? Can you find that?
I divided by 6.
Yes. So really just taking what we've seen, we saw a little chart that had degrees and radians. We saw parts of the quadrants. And now just at the top here, I'm seeing a lot of that information again. So, what are some things that we have seen before, right? We've seen degrees, we've seen radians, we've seen quadrants, and all those things are right here if we just focused on the top. So that's what I would do with my kids is if I didn't recap like I did with you, I would just say, okay, guys, what have you seen before? And hopefully they would say, oh, there's a quadrant. This is quadrant 1. Oh, I see 60 degrees. And I see that the radian that went along with it was pi over 3. So that's what we want to do on some of our pages is kind of help them remember there are some things you've seen before, right? That we were exposed to so many things, especially this new year, we might need a reminder of, oh yeah, I have seen this before. And then another question I'll ask is, do you see any triangles just in this little first quadrant? Do y'all see any triangles in this first quadrant?
Yes.
The
Yeah.
30-degree, the 45-degree, and the 60-degree triangles.
Yeah, and I like that they've made them different colors. That's very eye appealing to me. And I was sharing with another director because we were talking about, I think it was week 11. We were talking about one of the equations. I actually chose, when I wrote the equation on my board, I used different colors. So it will be helpful to like plug in numbers. And so it reminded me of this when we saw the colors again, is I like using different colors to show the different degrees, and now, you know, the different triangles. So that those are a couple of things that you can ask your students from this page. All right, now this is another slide that I wanted to kind of insert in. So let's say you have a Challenge 8 kid at home, but you have not introduced your younger ones. And so, you know, I wanted to show you that in the naturals booklet, week 16, and in the fractions booklet, week 16, we're doing the same thing. So really two things I wanted to show you here is, if I do have younger kids, right, I could download one of these in the beta, and they could be doing the same thing that I'm looking at with my challenge kid. Or if my challenge kid is just really overwhelmed at what he sees on this page, I could print out the naturals or the fractions and let them fill out the same things as well. For me, when I get ready for my community day, a lot of times I'll download the first 4 pages and I'll copy and trace, or I'll try to fill in the blanks to kind of get my mind ready for the complex booklet, like as a warm up for me. And so that could be something that your students might benefit from as well.
Babs.
Yeah.
This is Yating. I have a question. So looking at the naturals and also the fractions, the symbol that pop up to me is the symbol pi. And when we were doing flashcards at home, this is something like a symbol can have multiple definition, right? So in this case, pi is 180, right? Yeah, divide by 2 would be 90 degrees. But then pi also means 3.142. So how would you explain this to a curious mind?
So I personally would probably just say, in this case, we're going to just memorize pi over 3 because it's represents 180 over 3. I probably wouldn't go any further than that. I don't know if Kirsty wanted to expand, and if there was another way that you would explain it in a different way.
Sure. So pi is still 3.14 whatever, right? Pi is still pi. We haven't changed its definition, but we're saying that pi radians is equal to 180 degrees. So we have to think about what we're talking about. So we're not saying that pi is 180, but we're saying that pi radians, and remember that a radian is an angle measure that is where my arc has a length of pi, or a length of the radius. So it's around 57 degrees is 1 radian. So I'm saying if I had pi of these radians, and so I would stack them up, that I would end up with the same angle as 180 degrees. Did that help you out, Ting?
Yes, thank you. Just have a lot of, like, when it's coming to flashcards and notations, like M means something in Roman numeral, but then M also means medium and meter. And so one of my kids was asking, like, why can't they just make up their mind?
We need more letters.
Thank you.
Okay. All right, so now we're going to move on to I3. And now we see the unit circle in its entirety, and we have some little charts at the bottom. So I would ask my students, is there anything you notice on this page about how the numbers are arranged, or anything you notice maybe that you've already seen before, that maybe you didn't notice from the previous page? Tell me what you guys notice.
Well, this actually clears something up. We're doing week 13 right now, which is circles. And so the unit circle there, we were looking at it yesterday, and we couldn't quite figure out why 30 and 150 had the same measures instead of like, say, 30 and 120. Like it felt like they should repeat as you went around, and instead they were like inverse. I don't know if that's making sense at all, but seeing this diagram with the colored triangles, like I can see there's those triangles, those are isosceles triangles. So the sides, yeah, I'm not really able to verbalize it, but there's something that's clicked inside my brain just seeing the triangles drawn like this in different colors. That's very helpful to me.
That's
I
good
see
because
them.
somebody just told me Friday that they thought the unit circle was confusing, but the little chart at the bottom was very helpful. So I think it's so interesting how different people see different things.
And my little ones, now that they've done natural, they will point out the red lines are secants, and then the blue lines are chords, and then the black line is the diameter. So they are seeing things that they are learning in naturals, which makes sense.
That's great. So what do you think you would encourage your students to memorize from this page? Do you think the circle would be difficult, or do you think that would be more familiar, or do you think maybe a little portion of some of those charts you would encourage them to memorize? What do you think you would encourage them to try to memorize this week?
I think for me, I would zero in on the degrees and the radians as a nice starting point in the chart.
I think so too. To me, that's, I don't want to say the word easy because we probably shouldn't, but that does feel more familiar.
More familiar, yes.
Yeah, to just say, hey, 30 degrees goes with pi over 6, 45 goes with pi over 4. Like I feel like that's a little easier to swallow, right? And I told you that I asked my kids to memorize the quadrants. So if your kids haven't, I think this is a great opportunity to say, well, why don't we memorize, that quadrant 1 is here and quadrant 2 is here and quadrant 3 is here, quadrant 4 is here, and then whether they're positive or negative or a combination.
Or even that layered learning, adding, because we did talk about quadrants before, and so they're now adding some to their understanding or reinforcing the positive, negative. So it's good.
Mm-hmm.
I would take this as an opportunity to model for the students how to create flashcards out of what's on the chart. I've done this before with previous week's lessons, since we don't have flashcards for everything, just so they can start recognizing things. And so this would be one of the information from the chart would be something I would say, hey, let's go ahead and just make some flashcards. I'd make sure they have enough 3x5 note cards. And then I would have them create 1 or 2 in class. So then they can finish those at home. And I would tell them, hey, your flashcard box, like the flashcards you create, you can use those to, check that flashcard box.
That's a great idea. And we think about Latin, I know people have made flashcards that we buy, but I feel like if you make your own flashcards, right, it's another layer of learning, because then you're copying it, right, onto the flashcard, and then you're drilling. And so you get that double layer. So same way with the math flashcards. That's a great idea. All right. So I wanted to show you this. I found this online and I thought this was so cool. You can take the portion of that chart, you can hold up your hand and try to remember the degrees and maybe even the radians just by looking at your hand. So I thought I might do this with my kiddos, because there's just one thing that they can do that they're not just necessarily sitting and looking at a piece of paper, right? If I memorize that, my thumb is 0 and then I have 30 and 45, 60 and 90, maybe the next time my kid holds up his hand, it might trigger, oh, look, it's 0 and 30 and 45 and 60 and 90, right? And so I just thought that was neat. I saw that there's lots of things, that you can pull in. I know somebody was telling me that there's a unit circle dance, which I will not be doing that because I'm not going to learn it. But there's lots of things you can pull in if you want to do something a little extra like that. But this is just simple. It's not really a lot of planning required, but they can just look at their hand and try to figure out the degrees or the radians as they go. All right, so now we have the charts. And so they're very busy this week, right? Lots of great information. And I want to remind us that sometimes the charts are more of a reference for maybe the parent, not necessarily always the student. If you do have students and this is just too busy, right? A lot of information we've already seen this morning, right? We've already seen parts of these charts in our lesson pages from like the naturals and fractions, and we've seen them in the I pages. We've seen them in previous lessons. So, it's a great resource, but not necessarily always for the student. Sometimes, like for your kindergartner or your third grader, they're not going to be interested in looking at these busy charts. So that could be a reference for mom and dad, because they get to see this is where we're headed, right? Because these charts are the same in every single domain. So what I see now is the same thing the senior is going to see, that challenge 4 kid. So there's lots of things that we can point out that we've already seen if we want to help them realize that not everything is going to be new. But something that I like to ask my kids, and sometimes it's not just the chart, sometimes it's the I pages as well, is asking them, is there anything that you'd like to research this week that you see on the chart? It really isn't familiar to you, but you kind of want to dig in and look at it this week. So I don't think all students are going to be at that place, right? They might get to this page and say, nope, I'm good, right? There's a lot of information here. I'm good. But there are some students who are very inquisitive. They see a chart, they see a picture, an illustration, and they want to dig in a little deeper. And so I would definitely encourage you to do that if you have students that might have something that they want to research this week. So like I said, I would ask my students, what is something you've already seen? And we've seen the unit circle, we've seen parts of the quadrant, we've seen those significant first quadrant trig ratios. And so just helping our kids see that we've already seen a lot of this information. All right, so we'll take a minute here, and if anybody has anything to share from this previous week, like week 15, if you have questions or maybe even testimonies that you wanted to share, we can take some time right now and allow you to ask those.
I just want to take a moment to thank you, Babs. I had sent in an email pleading for help for Blue Books, and I pretty much took just what you gave me and showed it to my parents, and they all thought it was great. And so thanks to you, I have my Math Map Blue Book direction and questions, and I appreciate it so much. So thank you.
Good, good. I know there's a lot of families who are not necessarily using it full force at home. And so the more we can direct our Blue Book questions to things that we have covered in community, we've all hopefully looked at the art and the I pages. And if, we're trying to look at the tops of the first 4, if we can pull in things like that. And my hope is that if we ask them questions like, where do you see God in the art? Or what have you learned about God over the last 15 weeks? And those kind of things. And the parents get to see those answers. Like if I'm just picturing myself as a parent, like reading what my student learned about the Lord by this math curriculum. And I think that will be so amazing for a parent to get to see that. So,
yeah, I think it was amazing for me just as a director. My daughter's not in Challenge A yet, but looking at them, like when the curriculum first came out, I was like, well, I love all the art, but what's it doing in a math curriculum? But it's become my favorite part. And to have those kinds of questions come from it in seminar, but also for the Blue Books, it's just such a rich conversation. I think it's the first time I've enjoyed math. I can't say I love the math part. That's still hard for me, but to bring in the art and have a different way to look at math has really been a great experience.
That's great. And honestly, that makes it all worth it. For one person to hear that from just one person, I feel like Lee and Kirsty hopefully are listening, they're listening too. So I think that's a great testimony.
When my daughter loves the art too, she still won't come on camera, but every week when I come to the Math Map meetings, she hovers over here to the side to look at the art. and to hear what we're saying about it, and she'll ask me, "Are you muted?" So I'll mute so she can tell me what she's thinking, and then we sometimes come. So even she, who's not doing it yet, is enjoying that part of it. So any little bit that'll help us enjoy something about math is a brand new experience, and it's great.
That's right. That's right. All right. Well, let's go to our page 1. So now I feel like this page is very familiar, right? Sometimes when I get to page 1, I don't feel that way. And I think it's because I'm not spending enough time really attending to what is on the iPages, maybe even looking at the previous domains or looking at the charts. And so now you tell me what resources are going to help you fill out page 1.
Well, I literally highlighted this section on the I3 page, and then I opened up the chart when we got there, and I highlighted it again. So I know exactly where I'm going to go. Either one of those places is what I need.
That's right. That's right. And we need to make sure we remember to read the directions, right? I think I've shared this before that I have gone to Kirsty one time and said, "I don't really understand this page." And she would say, "Did you read the directions?" And I would be like, "Of course I did." And then I would look at it and it would just say read or copy. And I was like, okay, maybe I didn't read it. Maybe I was just really trying to understand it before it was time, right? I wasn't just copying or tracing. So yeah, we can do that. And so I put little pictures of what we saw in the iPages and the charts, and that's where we're going to pull this information from. And so that will be very helpful to us as we go through page 1 and then page 2. So one thing somebody told me Friday, which I was really glad that somebody recognized, is that sometimes we're going to have a page that's like super familiar. We don't have any trouble. Then we might get to a page that we wrestle with. And it's good to have both, right? So when I look at this one, I want to read my directions. First, it says study. Study theta, the sine of theta, and then sketch using degrees and radians. So first, it tells me that theta can be any real number. That's my domain. And that the period is 360 degrees or 2 pi radians. And so I'm just reading that out loud. I'm just kind of, trying to kind of study that and make sure I understand what that means. But then I feel like I need to study this chart, right? This chart is very similar to a chart I just looked at. It's a little different format, but some of the information is still the same. So now I'm going to go to the bottom and I see under simplify, I have the sine of negative theta is the same as negative sine theta. So if I input a number in there, the sine of negative 90 is also the negative sine 90. Okay, so I can kind of see a pattern there. Well, then I feel like I'm being thrown a wrench because they say, okay, the sine of 270 is also equal to the negative sine of 90. So I'm like, okay, what does that mean? So I go find 270 in my chart, and it tells me that the sine of 270 is -1. So I'm like, okay, well, does that just mean that the negative sine of 90 is -1? Okay, maybe. So I'm thinking maybe that's true. Well, I go back to my chart and I say, okay, well, the sine of 90, positive 90 is +1. So that makes sense that the negative sine of 90 is -1, right? So I really feel like it's just us slowing down to look at the chart, pull out information that we know, and that kind of helps us try to find the answers. Then we see the same information a little bit differently. Now we get to sketch it and we get to see the pattern or what it looks like. And so this is what it looks like once we've just traced. Now, if I don't understand all of it, right, it's not really asking me to understand. It's really just asking me to draw, right? I'm just tracing, connecting the dots, right? And so that's what I'm doing. I'm sketching the sine of theta using degrees and radians. It sounds really a lot more important to say it that way than connect the dots, right? And so I feel like, wow, I'm really important. I know how to sketch the sine of theta using degrees and radians. Okay. All right, so we're at the end. Wow, I feel like that went by really fast. So I don't feel like we do this enough. So I'm gonna say what's in black. I want you guys to say what's in orange. What are the solutions for?
To check work or work backward.
Good. What is in the inside back cover for?
To extend the conversation and fill the lesson 29 booklet.
Good. What is the back cover for?
To play
games.
What is the careful calculations page for?
As a
review or test.
What are the flashcards for?
So I can read math.
What is the Math Map companion for?
So my
parents can answer my questions.
And what are the lesson pages for?
To practice math concepts.
Good job. All right. And then a reminder of our resources. Remember that you can post questions on the forums. You can use your community and your director, your tutors as a good resource. We have the Math Map Companion that is online on CC Connected under week 7. You can always email us at themathmap@classicalconversations.com. And you can come here and ask us questions. And so we are at that time where Kirsty is going to be available to answer your questions. And so there we go. What questions do you guys have?
Thank you, Babs.
Absolutely.
Yes, thank you.
Babs is amazing, isn't she? Every time I hear her present, I think I wish my children had her as their Challenge A director.
Yes. Me too. Come move to San Antonio and direct for my kid next year.
I have a question from week 8. We're regrouping here a little bit. On page 1, where it just says study or trace the union of the finite intervals, like on the part next to the margin. I'm just wondering if you could read for me, well, just how that's supposed to read, like the set, union set, that, I don't know. I just wanted to hear it because my daughter had a question and I'm going to ask that today.
All right. So let me, so you said week 8.
Yes. Now I can't find you because I was looking at CC Connected. There you go.
And what page are we looking at? I'm sorry.
That's okay. I'm looking actually at, I can't see what page it is because, let's see. It's the same, on all the pages. So
sure. So looking at for example, page 1, let me share.
Yes.
I will share my screen and then
it says -∞3. So what's in parentheses, that's called a set, right?
Yeah. So the way I refer to these, so here, I've got this on the wrong screen, so I can't write. So I'm not going to, because it'll look like chicken scratch. When this is what we call interval notation, and what's sort of the hidden information here is that this is implying that X is an element of this set, right? And so that's the interval that X is. So I would say, it doesn't necessarily always read from left to right, because I would say the union of the interval from -∞ to 3 and the interval from -∞ to 4 is -∞ to 4. And I would be clear in those cases that that's exclusive, right? So I would say the union of the interval from -∞ to 3 exclusive and -∞ to 4 exclusive is the interval -∞ to 4 exclusive, right? And so by saying exclusive, I'm saying, hey, both ends of these are not included in my solution. And we see that that's it's the same thing below that, but now we're just using inequality language. So I would say the union of x less than 3 and x less than 4 is x less than 4. And then below that, I would say the union of the interval from 3 to positive infinity exclusive, and the interval from 4 to positive infinity exclusive is the interval from 3 to positive infinity exclusive. Does that help?
Yeah, 3. Well, it's the whole reading of it.
It is, right? I mean, yeah, I mean, it's that, and it's okay, right, for our students if they're working through this and they say, right, from 3 to positive infinity, not including my endpoints, in union with from 4 to positive infinity, not including my endpoints, is from 3 to positive infinity, not including my endpoints, right? So they may not always use sort of perfect mathematical language, but still be able to tell you what it means. And so I would say there's sort of an in-between step if you don't get to the most elegant and efficient way to read it, right? So mathematicians tend to go for efficiency, and then they'll also just describe things as being elegant, and elegant usually means that I'm condensing things and I don't have extra information, I don't have extra steps that I don't need. That's usually what they mean by elegant. But our students we don't get there overnight, right? That's when we're becoming rhetorical. So it's okay for them to go, I'm going to have to read this from left to right, and I'm going to describe it instead of maybe using the perfect words. But our goal is they understand it.
Since this week is equations, is it fair to say, so I think part of it, so my daughter's in challenge B and we're just doing it, and we're just gonna go through as the new levels are introduced. So she's not talking about it with classmates, but it's really, because it's equations, it's just for her to be seeing an equation is the same on both sides. Sorry, my friend back here is talking in her own language while I talk. I think she thinks I'm talking to her. So, I mean, is that right? Like she got a little like, well, what does that even mean? And I was trying to explain it, but.
So we're more, I think, right? We tend to be more comfortable with graphing in 2 dimensions because I have an X and a Y and I'm finding the relationship between them, right? And so in 2D, I get this graph, and I think it somehow makes a little bit more sense. But this is essentially a 1D graph, right? And so now I'm saying I am just graphing the value of X. Now, if I have an equation, there's just 1 point. There's only, or maybe 2, right? If I said like X squared equals 4, I could have X equals 2 and -2. And so now I have 2 values that I'm going to graph for X on my number line or on my axis. When I have inequalities, right now I have whole long ranges that I can describe. And so that's what I'm doing here, is I'm saying that what I'm really saying is, like, what are all the possible values of X that are described by this? Well, X can be less than 3 or X can be less than 4. Well, can I simplify that? Well, yeah, I can, because X less than 4 covers all of those. And so I'm just graphing that. I'm illustrating that. I'm graphing that on my axis. That's what we're doing here, is we're just saying I'm just showing graphically what are all the possible values of X. Does that help?
That helps a lot, because then in like 2 pages, the set goes in, the interval is in one direction and the other interval is in the other direction. So then it's the exact same thing on either side of the equal sign. Okay.
Yeah.
And so we're just illustrating what the possible values of X can be. That's language I can use that doesn't feel more confusing to her.
Yeah, that's exactly what we're doing.
Okay, thank you so much.
I have a quick question from lesson 12 about the polygons lesson. I had a mom ask me, she was looking at the chart. She's looking at chart 3 from lesson 12. and it says Venn diagram, properties of quadrilaterals. And she asked if this was actually an Euler diagram. And I wondered if you could give us just a little bit of clarity on why we're describing this as a Venn diagram and not an Euler. I gave her an answer, but I'm curious to know what yours is.
Well, your best answer there would be that this is really old, and this is an inattentive author here, who the first, right? So when we first were putting together the charts, they were rough, right? And we were like just kind of throwing stuff like, where does this fit? And I'm going to be honest with you, way back 7 years ago, we really were not clear on what was a Venn diagram and what was an Euler diagram. That is something that really we have refined over time. And when I say we, I mean me, right? I have refined my understanding. And honestly, I just never noticed that we never went back and changed that. So you can just tell her that Kirsty Gilpin made an error and she's going to fix it and make it say Euler diagram.
Okay,
That's probably not the answer you gave her, was it?
I said, well, it kind of looks like a Venn diagram within an Euler diagram because you have some overlapping things here. But that works too.
You're being really kind, but yes. So, and just to be clear, right? So I have learned so much in the past 7 years. Like I thought I knew stuff, and then when you start looking at it and you start looking at relationships and the way the math map is organized, when we look at things in different dimensions, all of a sudden you go, oh, wait a minute, these, like all of our education, right? I mean, I grew up without an integrated education. So I learned one thing over here and I learned another thing over here. And I was really good at having parallel tracks in my brain. And I probably shared here on the book club, right? Like there was biblical history and there was like school history, right? And never were they integrated until I started teaching my children. I never thought that I had two different pieces of information in my brain. And so one of the things that's happened over the course of 7 years is that I have learned so much. And God has been so gracious to reveal to me so much truth as we've looked at math a different way, as we've taken and arranged it differently, and examined it differently. I've seen integrations and connections that I was never introduced to and had never looked for before. And so this is one of them. And so we're all learning. It's really tempting to go, oh gosh, they wrote the math map, they know it all. But we really don't. We may be just a little bit ahead of you on the learning curve. So I will fix that today. And now I'm going to scroll up so everybody doesn't have to look at my mistake.
So just to be clear, so what you're going to change is for it to say Euler diagram rather than
Yes,
Venn.
right
Okay.
here, I'm going to change this so that it says Euler diagram.
Okay.
What would be a great exercise with your kids, especially if you have
Hello.
some older kids
Hello,
that
can
are
you hear me?
working through this, is I would say, hey, what would this look like if we were drawing a Venn diagram, right? Where would you draw a Venn diagram? How many different sets do we have? And what would that Venn diagram maybe look like? And that might help your students see why a Venn diagram really wouldn't be helpful here, because we'd be looking at all of the possible intersections of all of these sets instead of just the ones that are true. So I wouldn't do that with your first year Challenge A students, but if you have some older students that are working through the math map with you, that could be a fun exercise. All right, Nicole, what was your question?
Hey, I'm sorry if I was interrupting you. I forgot I had like earbuds that I could attach to this thing, but I wanted to go back to the negative infinity 3 union negative infinity 4. I've been saying negative infinity unified with like negative infinity 3 unified with negative infinity 4 is negative infinity 4. Is that improper?
No, it may be, it's not, but you may want to add in that inclusive or exclusive language to really identify, right, that because if, well, I would never have a bracket there, but I could have a bracket here, right? And I could have a bracket here, or, you know, one or both of those, and that would change, right? If I had a bracket on my 3 but not my 4, my union wouldn't change. But if I have a bracket on my 4, then I would have a bracket here. So that would be a difference, right? Because if those were brackets, now all of a sudden these are filled circles. So I would say, as you're saying that, I would encourage you to include whether or not that's apparently it doesn't want me to fill in that circle. But I would encourage you to include that, whether we're talking about an inclusive or exclusive interval, including or excluding those endpoints.
Okay. Oh yeah, I do see that. Okay, and just to kind of back up what you said about learning things separately, I was today years old when I realized that the circle is on the quadrants that we learned when we learned X and Y axes. Like I literally just put those two things together today. So I'm like, oh,
You learned
makes
something
so
today.
sense now.
Yay.
It's funny because, when Babs is talking about memorizing the quadrants, right? It may seem like, well, everybody knows, right? You just count. But it's really, really important for us to remember that our students who are seeing this for the first time, who are grammarians, that things that might feel obvious to us because they're familiar really aren't to them. And so being willing to go back and say, hey, let's make sure we're all on the same page, I think is really important.
And I think the most brilliant thing, I mean, there's been a lot of brilliant things happening on these calls, but for me so far, the most brilliant thing somebody said to me was like, go back and print the naturals and do it side by side. I'm like, duh, that makes so much sense, because now something that's super complicated, I'm looking at it at a very elementary level, and suddenly I'm like, oh, that's so that I think I appreciated that, because I remember you saying we kind of have been plopped down in the middle of this, and that's pretty helpful. So do it.
That's great.
Thank you.
Oh, thank you. Any other questions today?
I have a question. I have really enjoyed being on here on Wednesdays, and I'm a Challenge A director. I'm using this with my Challenge 2 son, and next year I'm just kind of looking to the future. What is your vision? Will you still hold these classes whenever we're in monomials, and you'll be using monomials as your weekly lessons? Because I just get so much out of just sitting in your presence, and I look forward to it. Like, it's blocked off on my calendar. I'm going to be here on Wednesdays, but I'm not sure I could do this without y'all.
Well, one, you can, right? We don't remember. So one of the things that I heard recently, and I hadn't, and I'm sure that they've been saying it for years, but it really clicked, was that we can't always be with you, right? But you can always have a friend with you. And that's one of the ideas behind Classical Conversations is things are easier when we have a friend. When I have a question, if I can call another mom and say, hey, did you get this? What's the assignment? We missed this. Help me out, right? And so the tutor is oftentimes that person, but it can be another mom. Sometimes it can be our students, right? How many times have we relied on our kids to help us with something? And so as the math map rolls out and we have more and more families that are using the math map, right? Think about if everybody in your community is in the same booklet every week. Think of the number of people that you can talk to about what you're doing and be encouraged and equipped. And some days it's you that's doing the equipping, and some days it's somebody else doing the equipping. So I really want to say, as much as we love having everybody here, you don't need us. You really can do this if you didn't have the book club. That said, my understanding is that the vision is to continue having the Math Map Book Club. we will finish out the this academic year going through complex. We're thinking about some different ideas over the summer. We may look at some of those games and activities over the summer as a sort of something a little bit different, but be a great opportunity to dive a little bit deeper into those. And then I'm not sure what next year's format will look like. I don't know if it will be exactly the same as this year, simply because it's going to be really similar. And so for somebody who's like, I just want to go through the booklets, you could go and watch the recording. So we may do something different. We may next year perhaps pull in some of those new domains. Maybe we'll look at a couple of pages from integers and then a couple of pages from monomials, right? We might say, hey, let's look at two really different domains that we've released at a time and do some comparative work. So the long-term plan is, yes, we will be here because we want to really encourage this community that we're building. I love not just the community you have with us, but the community you have with each other has been so encouraging for us to see growing. But at this point, I can't promise exactly what that's going to look like.
Well, I do appreciate all that you guys have done, and I feel like I absorb so much every time I'm on the calls, and I'm watching when I miss them, so it is really a benefit. Thank you all.
Oh, it's really encouraging to hear that. Thank you.
I agree with that too.
I'll just say that I definitely feel like I'm understanding more that this is to equip parents to be able to teach their kids. It's not to skip over the parents and just kind of put something in front of the kids. It's definitely equipping us. And so I understand for parents who just don't want to do this, they don't want to take the time to get equipped, that outsourcing math was kind of what they did. That's a different target market for lack of a better word. And I think I more and more understand the purpose of it, right? It's not just about getting your kids to get through this and check off math on their transcripts. It's about equipping parents to be able to help their kids understand math all around them, which is not anything I wanted at all.
But
I'm very glad.
what you just said. I love what you just said. Thank you so much, because that is absolutely the heart behind this. One of the things that I said a couple of years ago, there was somebody who was like, well, test scores, and how is this changing test scores? And I was like, no, test scores aren't going to be what woo people over. What woos people over are the moms who go, oh, I didn't know math could be like this. I didn't know I could find God in math. I didn't know that my perspective could be changed. And that when moms go, oh, wait, this is mattering to me, then it's going to matter to their kids. Right. And so that's really, I appreciate everybody that's on these calls, because I see you guys wrestling with your own math understanding. And that can't help but translate to your families and your communities. So thank you.
To your point, Nicole, about, that it is for the parents and that maybe we didn't really want to learn it all. I think that because I now see math everywhere, it actually learning math, and this was one of the quotes in one of the books, that if we're going to learn other things, we should learn math. And I think it was Mary Shelley who said that, about if you're gonna apply yourself to thinking in other areas, don't skip thinking about math. And I think that it helps me. Like, I have 4 children, and only now am I really understanding enough to have a solid conversation with my children about chemistry or about music theory. And it's because of math. And the other one, they did it, and I read to them, and I bought them coffee, and they took notes, and I said, do you get this? And we worked through it. But it is so much easier. And I think too, recognizing that I can learn something that was unfamiliar to me and that felt hard, has given me hope that I can learn other things that are unfamiliar or that look hard. And so, because I used to think people would, my youngest is a junior, and I'm like, what am I even going to be when I'm not homeschooling anymore? And someone said, oh, you'll keep learning. I'm like, you give me too much credit. I am so not going to be doing any more learning when there is no one that needs me to learn anything. But enjoying this makes me think, you know what? Maybe I will. So it fills out the whole family. It fills me out as a person, and my kids just get a more engaged homeschool mom because of it.
Well, guys, as always, I will be the last one to jump off. So if you still have questions, but thank you so much for being here. Thank you for sharing and asking questions and encouraging one another. We hear you when you say you appreciate us, but we really, really appreciate you. And the Lee's vision of building math community, right? You guys are the first expression of that. And it's really encouraging to see all of you go, I didn't really want to do this, but I am. And so it's inspiring to see you all putting in the time and wrestling with these ideas and just like Jill said, right, becoming engaged and excited and a better mom. So thank you all. Have a great week. And we have one more week where we have a lesson we're going to go through, and then we're going to sort of just chill out for December and answer questions, maybe play a game or two. So come back next week for lesson 17. And then after that, it's all fun. 17's fun too.
It's all fun anyway.
Yes.